Okay, Josephine, how about you? What do you see?
Think I see black and white, mostly because of the two large asymmetrical triangles at the sides.
Okay, so if we see black triangles drawn on top of white, imagine the triangle is initially completely white, okay? And in terms of what you see here, if this is the biggest triangle, the largest one that we see here, how many smaller substructure triangles do we see? So by substructure, I mean just smaller than the biggest triangle that we see.
I think I see three.
Can you show me where those are?
One is here,
That's right.
then one on this side, and another one here.
That's right. So imagine that we're recursively trying to solve this problem. We would say, well, we solve the bigger problem, namely the big triangle, in terms of the three. Now let's suppose that we're thinking about this as black on white. So we see a white background, and we're going to divide this into thirds. But in terms of drawing black, if I think about this next smaller triangle, is it time to draw black yet, or should I wait?
We go all the way to the smallest case, then we draw black.
That's exactly right. So the triangle that we see here is still completely white, and inside of it are three triangles, each of which is completely white, until we get to the smallest triangle we're willing to consider, and at that point you would draw it completely black.
Yeah.
Perfectly valid way of looking at the triangle, leads to a great solution. But another way to think of this is that it is white on black. Do you see it that way, Casey?
Yeah. Except they're upside down.
Pardon me?
They're upside down triangles.
Upside down triangles, right. Oh, good point. Okay, so think about the large triangle as being completely black to start with, right? Do you see the same three subtriangles that Josephine saw, namely here, here, lower right, and also lower left?
Yeah.
What would be my act, though, in terms of dividing the large black triangle into the three smaller black triangles? What would I have to do?
I guess you'd have to draw that big white one in the center.
Yep, so I'd have to draw this big white one here at the center. Having done so, I then get three black triangles, each of which look like my original triangle. When I treat them recursively, take the top one. Where would I draw its white triangle to break it into three pieces?
Again, in the middle.
Do you want to show with the mouse where that would
Yeah.
be?
Right
Exactly,
there.
exactly. So each time we recurse, we're getting smaller and smaller triangles, and we're drawing the white triangle, creating three smaller sub-black triangles. In the base case, do I need to draw anything, or do I simply give up?
I guess you would just stop when like the triangle is a certain area.
Exactly. So each of these black triangles we see is just like the original huge black triangle, except we gave up on further recursing and dividing it up. Great. So this is an example of how to find recursion in a figure instead of in a formula, and it involves looking at the figure, finding the substructure, and then reasoning about the recursion.